From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show.
How many of you saw the Flutter Live event held in London on the 4th of December 2018? Google announced Flutter 1.0. We've talked about how awesome it could be building apps with Flutter, but at the same event, a startup in Estonia partnered with Google to announce a brand new CI and delivery service tool called CodeMagic. This startup is Nevercode, and Nevercode built CodeMagic. Today, I'd like to thank them for sponsoring this show. CodeMagic is the first CI/CD tool created exclusively for building Flutter applications. The idea for them was, without any deep technical knowledge, app developers like us should be able to easily configure the whole flow for the Flutter platform to the users of our app on the Play Store or App Store. Because remember, with Flutter apps, you can easily build both Android and iOS applications. It's a cloud-based CI/CD tool for building, testing, and publishing Flutter apps. Users log in via GitHub and select the repository containing their Flutter application, after which they can immediately start a build with pre-configured defaults. Even the folks at Google working on Flutter have had great things to say about this. For example, Tim, the group PM for Flutter, said this: Nevercode has a really good understanding of the workflow that Flutter developers want. Their CodeMagic product takes all the pain out of the build process. That's pretty cool. So if you're a Flutter dev, build, test, and publish your Flutter apps in record time with CodeMagic. Go ahead and check them out at codemagic.io. But here's the kicker. For the time being, the tool is available to everyone at no cost because they just announced it. It's totally free, but in the future, it probably will include paid options in addition to the free plan. So you should check them out while they're still hot from the presses. Thanks for sponsoring today's show, Nevercode. If you work on an Android app, and if you're listening to this podcast, I'm going to presume you do, you'll know that when your user reports a problem or a crash, it's the absolute worst feeling. To make matters worse, they might one-star your app, go on Twitter and complain about the app, and if they're feeling particularly merciless, probably go on Reddit or something and post it there. But you know what? They have absolutely every reason to. If you treat your customers basically as an off-site QA team, it's rude to them and it's just bad for business. As developers, we don't want to rely on customers to report errors. Instead, we want to catch this much early on. Ideally, you just have automated tests and these tell you when there's a problem. But, as we've talked about on the show multiple times, that's not always as easy as we want it to be. Because writing tests can be hard. That's why Sentry, our sponsor for today's show, tells you about errors in your code before your customers have a chance to encounter them. Not only do they tell you about the errors, they also give you helpful details that help you fix these errors. For example, how many users were impacted by this bug, the complete stack trace if it's a crash, the commit ID when this error was released, the engineer who wrote this line of code that was busted, that and a whole lot more. If your code is broken, let's fix it together. That's Sentry's tagline. I love it. You can check them out at sentry.io/for/Android. Sentry is a pretty common word. It's actually a pretty cool name for the service if you know the English meaning of the word. But I want to make sure you get that domain name right. It's sentry.io. Once again, sentry.io/for, as in FOR/Android. Check them out today and fix your errors before your users encounter them. Thanks for sponsoring today's show, Sentry. So it's been some time since we did a Learning Kotlin episode, so I thought I'll do a quick and short fragment today. Back in October 2018, around the time of KotlinConf, JetBrains released Kotlin 1.3 with coroutines, Kotlin native beta, and a bunch of other good stuff. I'll post a link to the show notes for all the release announcements then. But a feature I was eagerly looking forward to that kind of slipped my radar was inline classes. So in this quick fragment, I'll run through some of the basics and why you would use this feature from Kotlin. Now, before we start, if you're a studious listener, you'd notice that we kind of dealt with this whole inline thing already. In fact, in episode 116, we actually talked about inline, no inline, and cross inline. That's fragmented episode 116. I'll, again, links in the show notes. The difference, however, is that in that episode, we were talking about those keywords in the context of functions or methods. The whole new thing that JetBrains introduced now with 1.3 is inline classes. So it's in the context of using that keyword in classes. If you haven't been following this stuff closely, it's quite easy to just miss that detail, but inline classes are pretty cool. So what are inline classes? The easy way to think about this is if you ever need to wrap business logic around a type, this is the feature to use. You want to think strong types and simple values. I cannot necessarily take credit for this pretty cool phrase. This is actually from the blog typealias.com that writes on a lot of Kotlin stuff, which is a pretty cool blog. So I'll post a link to that, and you folks should definitely follow that. So when exactly would you need something like this? The best example that made it most immediately click for me is the example of time. Say you had like a local API to send push notifications after a certain delay or a time interval. The push notifications might take in, say, a parameter for that delay. But internally, the parameter for delay is represented as a long for milliseconds. And you're like, oh, that's weird. Almost always your use case when you maybe use something like a push notifications is to take a value that's represented in minutes. So why not just take minutes? Because otherwise, if you have to pass the minutes into the milliseconds, you'll have to like do the conversion. And say if you want to send a day or something, then you have to do like even more conversions. It kind of makes it tricky and allows yourself to be open to bugs if the person who's consuming the API doesn't clearly understand the parameter, right? So what you can do is you can introduce a wrapper class called minute, which has a transformation internally to milliseconds. So that way you can just easily use the same API and just send in a wrapper class called minutes, which internally then transforms that into a millisecond, into milliseconds, so that your lower APIs can use this and nothing changes in that front. So it's almost like you're allowing the API to be consumed more nicely because you're adding this wrapper business class, which almost enforces the logic of conversion from minute to milliseconds. So now the consumers of the API know exactly what that delay parameter is because the type of that delay parameter is now minutes. And internally, as I mentioned again, it's represented as the same long that we use. So it makes it less confusing for the person who's using that API. Now, this is great. But if you think about it, there's some problems with this. You're introducing a new wrapper, almost useless class, right? Because this minute wrapper class literally just has a single primitive called long, right? So if you think about it hardly, there are performance implications. There's a runtime overhead due to additional heap allocations. Also, if you're using a wrapper class for primitives, as JetBrains does point out in the docs for this inline classes, it's additionally worse because the performance hit relative to a simple primitive is actually pretty huge. What does that mean? That means if you're using this wrapper class for something as simple as a primitive, you're actually taking a much bigger performance hit. Now, the reason is because traditionally, the JVM optimizes the heck out of primitives, which is also why it's a good recommendation to always use primitives if you can, right? So what would you do in this case? You want to enforce a type and add this functionality in making the API more consumable, but at the same time, you don't want to necessarily take a performance hit. So would there be a way to get the benefits of this type-driven design without a performance implication? That, my friends, is why Kotlin has introduced inline classes. But the absolute cool feature here is that in terms of performance, there's absolutely no hit, because what Kotlin has done with this feature is it's super cool. At runtime, these are eventually represented in the base types you actually used in the inline class. So if you used a primitive type in the inline class constructor parameter, in the compiled down final version of the code, it still remains a primitive. So for this time example that I mentioned, if you look at the final compiled down code in the JVM, it'll still be represented as the long primitive. And you get all the optimizations that the JVM has made for those primitives. So I think it's pretty cool. Also, with this topic, we casually enter the wonderful world of what is called type-driven development. Now, this is a massive topic in itself, but what I'll do is I'll leave you with some really great resources that I've bookmarked for myself that point towards like some really cool concepts around type-driven development. The first resource is by this person named Michael Feathers. So Michael Feathers, Don and I are big fans of Michael Feathers. He's written the book Working Effectively with Legacy Code. It's one that we have recommended in multiple episodes here at Fragmented. It's a fantastic book in itself. But he has this talk called Type-Driven Approach to Functional Design. It's a beautiful talk. I've listened to it once already, and it's one that I have bookmarked. So definitely listen to that one. We've also in a previous episode talked about this programming language called Elm, E-L-M. It's a beautiful language. There's a blog post that someone's written that I'll post a link to. The name of the site is becomingfunctional.com. It's type-driven design in Elm is the name of the blog post. I'll put a link in the show notes to that. Again, superb post just to get a sense of this whole type-driven design concept. And lastly, there's this in the world of functional design, there's this author named Mark Seaman. He's written a blog post on type-driven development, and I'll add a link to that. That one is a little heavy. He tends to go into like a lot of the details of functional programming, but it's nonetheless a great topic. So these are some great resources for type-driven development. Now, coming back to Kotlin's inline classes definitely help towards driving your code to a type-driven design, which is why I'm bringing up some of these resources. If you want all the good details about inline classes specifically, as someone who uses Kotlin a lot, what you should do is also take a chance to read the KEEP. That's K-E-E-P. It's the KEEP proposal. This is all maintained by the good folks at JetBrains for Kotlin in GitHub. I'll post two links. One is to the proposal itself for inline classes, and the other is the issue on the KEEP, which has a lot of the discussion around inline classes, at least at the time of when it was being developed. As you get more familiar with Kotlin, I recommend you, like all you folks, definitely take a look at these discussions and the GitHub issue, because understanding the intention understanding the history as to how some of these features came into being really grounds your understanding in these concepts. So I'll post a link to that as well. This episode is going to have like a chock full of interesting show notes that you folks should definitely look into. Diving into some of the details for inline classes, the first thing is inline classes support some of the functionality from regular classes that you would expect, in that you can declare properties and functions, which is pretty cool if you think about it. That being said, there are some restrictions for inline classes. Firstly, you cannot have inner classes. So they can have properties and functions, but you cannot have inner classes inside an inline class. They also only take in a single property, and that too, it has to be initialized in the primary constructor, and that property, that single property, that constructor parameter has to be a val. So it has to be it has to be read-only. Also, they cannot have init blocks or backing fields. You may then ask the question like, well, with this whole type thing, can I inherit from inline classes? So if I have an inline class called minute, can I maybe inherit ours to have like 60 minutes and so forth? actually, that is not possible. Inline classes can only implement other interfaces. So in the world of inheritance, if you think about inheritance, inline classes can implement other interfaces that you specify. But actually, inline classes have to be final, and they cannot extend other classes, if that makes sense. And you cannot obviously extend from inline classes. Basically, they're forbidden from what is called class hierarchy, which, if you think about the functionality that it's trying to achieve, it seems obvious. Now, for those who've been following Kotlin closely and who've been listening to some of the episodes, in episode 122, we talked about type aliases. So you may bring up the question again, isn't this pretty much the same as type alias? So JetBrains has a very good explanation of the specific difference between inline classes and type aliases, and I'll point to that resource. But in a gist, if you think about it, both features introduce a new type for convenience. So for convenience sake, it's nice to just use these types. So that's the commonality between inline classes and type aliases. Both features will also be represented by the underlying type at runtime. So this cool feature that I just talked about, where like you're not taking the performance hit because it's using the underlying data structure that's represented. Type aliases also have this. So they're very similar in that aspect too. The big difference though, and this can seem very word jargony, but it's very important to remember, type aliases are assignment compatible with the underlying type. Inline classes are not. This is a huge difference, and this actually in many ways helps drive towards that type-driven design. Type aliases, and JetBrains uses this term, which I like. Type aliases introduce an alternative type. However, inline classes really introduce a new type altogether. So basically, inline classes, if you think about it, are way more stringent and in most cases what we want. Say if I have two inline classes, again, another example, and another good example for this is currency. So I have dollars and euro, or maybe I have dollars and rupees. Rupees is the currency for my home country, India. I want the compiler to vigorously fail if someone in my API swaps dollar and euro or like dollar and rupees, because those conversions are crazy, right? If you think the underlying type might be represented as something as simple as a big decimal or a float, but the trouble is, if it is assignment compatible, I can, in an API that is, because it's consuming this money object, I could, instead of a dollar, also send in a euro, and the compiler won't actually cause any problems if dollar and euro were simple type aliases. However, if I use an inline classes, because they are not assignment compatible, in this method that's taking in a dollar money alias, if you send in a euro, it actually will fail in compile time because they, as it is said, are not assignment compatible. Even though both the underlying data structure in both of them are big decimals or like floats, the compiler will actually fail. And the important thing to realize is in type aliases, it actually won't fail. And this can be really dangerous. So in many ways, it sort of almost gives you the convenience of type-driven design, but it doesn't give you the benefit, which is you want things to fail on compile time, and you want it to be more specific and contained or constrained by the type. So if you think about it, inline classes definitely are much better to use than type aliases, especially in this whole type-driven design model. So just to recap on that specific concept, in type aliases, they're both, if you have an object that's both represented underneath the hood as the same thing, like big decimal or float, at that stage, the compiler is tricked into thinking that it's the same thing if you're using a type alias. But in inline classes, you actually prevent that. The compiler knows very clearly at that time that you cannot swap these two types. So in other words, they truly bring in the idea of type-driven design. Also, a quick note, don't represent your currency as float. I know some of you who listen to that might have almost had like a knee-jerk reaction. That's a good reaction to have. You never want to represent money as float. My preference is to represent money as the smallest denomination, whole, integer, or long, or substitute with the data structure that will hold your type. Listen to episode 132 for details on that. And before I wind this short fragment down, one last caveat. Inline classes are experimental. Womp, womp, womp. Well, in JetBrains' own words, this means the design of inline classes is experimental, meaning that this feature is moving pretty fast and no compatibility guarantees are given. So when you actually use inline classes with Kotlin 1.3, you'll actually get a warning saying that this feature is experimental. This warning can be pretty annoying if you use it. So there's a way to disable it. You just have to opt into the usage of experimental features. And you can do this in Gradle by passing in like specific command line arguments. Again, I'll post some resources to how you can do that. So this is a huge topic, and there's a lot of more exciting things to discover about inline types and the whole idea of type-driven design. I almost want to do an independent episode altogether just on type-driven design, because it is, you know how they have these waves of sort of ideas and concepts that have been flowing from the functional world into like the regular world, in quotes, for regular programming world. Type-driven design is one of those concepts that I think is like just very good in general for safe programming. So I'm excited about that. And maybe if folks think it's interesting enough, just let us know. We'll try to do another episode just on type-driven design and how we'll try to fit this concept of inline classes in there again. Also, Jake Wharton, he recently posted a blog post on this subject, which actually reminded me of this feature. In the blog post, he mentions how inline classes can make great database IDs. So if you've just understood what I've talked about so far, you will almost immediately grasp the concept right away, right? As against like regular IDs that you use in your database. It's in the context of SQLite, which by the way is another awesome SQLite database library. So definitely, I won't go into the details right now about that. Just read the blog post. I'll post a link to that. That it also, again, as soon as you've understood these inline classes, if you go and read up on some of these blog posts and the use cases for inline classes, it'll just click that much better. Hope you enjoyed this fragment. Again, I've talked about a whole bunch of links and resources. All of that will be in the show notes. Definitely take a look at that. I hope you enjoyed this Learning Kotlin episode. I will catch you in the next one. I want to thank Sentry for sponsoring today's show. Their tagline is, "Your code is broken, let's fix it together." They're a super cool crash reporting service that gives you all the helpful details that you need when detecting and fixing errors in your application. Don't wait for your users to report your errors and crashes. Use Sentry to catch them earlier. Check them out at sentry.io/for/Android. Once again, because Sentry is a common word, I want to make sure you get it right. Sentry.io. My thanks to Sentry for sponsoring today's show. And before we wind this show down, I also want to thank Nevercode for sponsoring this show. Specifically, their brand new cloud-based CI/CD tool called CodeMagic. They partnered with Google and released the very first CI/CD tool exclusively for building Flutter apps. Build, test, and publish your Flutter apps in record time with CodeMagic. Check them out at codemagic.io, while the service is still available to everyone for free. My thanks to Nevercode again for sponsoring the show. That's it for the show, folks. Fragmented is hosted by Don Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.